Hello there, it's Jason Gorman from Codemanship here with the fourth video in our series on test-driven development in Java. If you've missed the first three videos, I highly recommend you take a look at those first. There'll be a link in the description below. In this video, we're going to be talking about the relationship between duplication and design. If you think about it, duplicate code is the opposite of reuse. So when we remove duplication, we end up introducing reusable abstractions. And so from a design point of view, duplication in our code is very, very interesting. So we should pay particular attention to that when we're refactoring after passing each test. Now, I'm working on an example here for the Mars rover. This is an exercise you can find online. I'll post a link in the description below. And the requirements for the Mars rover are very simple. We want to be able to drive our rover across an idealized XY grid that represents the surface of Mars. And it can be facing in one of four directions, north, east, south, and west. And we can turn it right or left, and we can make it go forward and back. And we can issue sequences of those instructions, R for right, L for left, F for forward, and B for back, to the rover so that it will execute a sequence of moves. Now, I've made a start on this. I've done 3 test cases for turning my rover to the right. So I've been triangulating this particular behavior for turning right. And as you can see, there's some duplication in our test code, and there's also some obvious duplication in our implementation there. Now, the next question is, when do we remove the duplication? And it's important not to jump in too early. The risk when we refactor code to create abstractions is that we end up introducing the wrong abstractions. And that very often happens because we haven't seen enough examples to sort of see what the pattern is yet. We have to see the pattern. So I operate on what's called the rule of 3. This is a popular design principle in software development. The rule of 3. Basically, on average, I must stress on average, it's not a hard and fast rule, but on average, I wait to see 3 examples of duplication before I refactor it, so that there's a better chance that I know what the pattern is, there's a better chance of introducing a useful abstraction, but there's also an increased chance, the more examples we see of something, the more likely it is there's going to be more examples. That's just the way the world works. So it's more likely that we'll get to reuse that reusable element again, so it will make our life easier going forward too. So the rule of 3 can be very, very helpful here. It also helps to avoid waiting too long. So if we wait for the 4th and the 5th and the 6th example, the more duplicate code we have, the longer it's going to take us, the more effort it's going to be to remove that duplication. And in software development, we have finite time. So if something takes longer, it's less likely to happen. It's as simple as that. Again, that's just the way the world works. So to avoid waiting too long and risking not doing the refactoring at all and then ending up with lots of duplicate code to support, we wait for 3, and to avoid jumping in too early, we wait for 3. Now, as I said, that's just an average. On average, sometimes you can see the pattern straight away, and in future videos, we'll be doing a little bit of that where it's obvious what the pattern is. Sometimes you need to see more examples, but hopefully not too many. So here we've got 3 examples, and I think I can see what the pattern is here. If we're facing north, face east. If we're facing east, face south. If we're facing south, face west. If we imagine that we have a compass, let's invent this thing now, as an array of strings, north, east, south, and west, in that order, and the order is very important. Then all we're really doing here in our go method is we're saying, whatever way you're facing in the compass, you need to move to the next one in the compass. So index plus 1, basically. So if we imagine we have an index, we can find out what way we're facing in terms of the compass index. then we can just set ourselves to the next one in the compass. And that is the pattern. Okay, now let's get rid of these. We don't need these anymore, hopefully. So what we've done is we've substituted a more general algorithm here that involves moving one in the compass, moving clockwise, if you like, through our compass. Hopefully this will work. Good, excellent stuff. So our go method has been somewhat simplified there. Now, let's look at the test code. There are people out there in the world, even people who teach test-driven development, who will tell you that you shouldn't remove duplication from your test code. Now, what they mean is sometimes when we remove, for example, duplicated setup code, when we've got lots of tests with the same setup, we can end up in a situation where the tests get harder to understand because people can't understand the setup, they can't see it. When you do remove duplicated setup code, it's very important if you create, for example, helper methods to do your setups, to name those methods very carefully so that you don't need to look inside them to understand what the scenario is. But there is, if you've got 3 tests here, for example, that are pretty much the same behavior, just different examples of the same behavior, there's a much more straightforward way of removing this duplication from our test code. And it is good, if you can, to remove some duplication from your test code. Otherwise, you just end up with a lot of test code to support. So we are going to remove this duplication from our test code, and we're going to do it using what's called a parameterized test. A parameterized test is just a test method that accepts parameters. It's as simple as that, so that we can reuse it with different test cases. JUnit 4, which I'm using here, has built-in functionality for creating parameterized tests, but it's a little clunky. It's not very good. So I'm not going to be using that. I'm actually going to be using a separate library called JUnit params. Let's see if we can, let's bring up our module settings and add that. Okay, so I'm going to add this from Maven. See if I can remember. Pragmatists. There's a tough word. JUnit params. And the version I'm going to be using is 1.04. There we go. Hopefully that's the one. Seems to have found it. Lovely. Okay, let's apply that. So what I need to do here, I'm going to have to do it in a single step, I'm afraid. So it's a bit of a fiddly refactoring. You say, okay, let's start with our parameters. Let's introduce them. We'll use the tool to do this. So it starts facing north. I can't run the test at this point because the test will be broken. So I've got to do this all in one go. So let's do it quickly. Ends facing. Okay. What's going on there? It's created a delegate there. So, yeah, I don't want you to do that. Thank you. Oops. That's what we wanted to happen there. Do apologise, I've been stuck in other tools for the last few days and I'm just re-acclimatizing myself with, refamiliarizing myself. Now, the way that we can pass in parameters, a simple way to pass in parameters in JUnit params is as an array of comma delimited strings, and each value inside the string separated by the commas needs to match these parameters exactly. So in this case, for example, north and east, and no, so we're using that. And then finally, the final step, if I remember correctly, is we need to get this to run it with the right test runner. And it's the JUnit params. Did it do all those imports? It did indeed. Lovely. Right. So we should be ready to rerun this test now. but this time as a parameterized test. And we can see now that it's added, so that's our test case, north and east, test number 0. And that essentially means exactly what it meant before. It's just now we're passing those test data values into the test, which means that this test can now be reused. So we can go east and then south, and we can go south and then west. Let's rerun our test, just make sure it's picked up all those cases. So there's all 3 of our tests there, which make these 2 duplicated tests redundant. We can get rid of these. So you see there are a lot less test code. You do need to be careful with parameterized tests that they are easy to understand. They're easy to read. And sometimes I find that it is useful, for example, to do something like that. So that we can see how many, at a glance, these are the test cases. So whatever you can do to make your parameterized tests easier to read. And one final bit of business here, the name of this test is now misleading. It's not just north to east. So what's the general rule here? We turn right clockwise. So there's an opportunity there to rename the test. So now it describes the rule and not the example. So when we read our test code now, we see, turns right clockwise, rather than turns right from north to east, turns right from east to south. Well, you have to sit down and go, well, what do all those examples have in common? So it makes our test read more like a specification as well. So it's a double win here. Less test code, but also it reads more like a general spec rather than just a list of examples. And as you may see in videos I'm going to do in the future, not about TDD but related, parameterized tests have some powerful stuff that you can do with them as well once you've done that. So I'll often take the opportunity to parameterize duplicated test cases, because that can be a jumping off point to other kinds of testing that can be very powerful and useful. So we removed duplication from our rover. We've removed some duplication from the tests. And now we're going to see whether or not that's been worthwhile. And I believe the proof of the pudding is our final test case going from west back round to north. How long did it take to write that test? No time at all. So it was worth refactoring that duplication in the test code, because it's made it much, much easier to write the next test. And that's a good test of whether our refactorings are working. Is the next test easier? And if it's not, then, well, maybe it hasn't made any difference. So let's go back to our rover now. How do we pass this test? Well, we want to go round in a circle, really. We want to loop back to north. So an array with 4 elements, if we were to use the modulus of index plus 1, so index plus 1 mod 4, in other words, if the index is 3, which is west, and we add 1, so the index becomes 4, 4 mod 4 is 0, so we're back to north again. So let's just run that and see what happens. Super duper. So we're really getting somewhere now. We've done turning right, all 4 examples of that. And now we're thinking about how do we turn left. Now I could extend this parameterized test to include an instruction as well. So is it left or is it right? So I could reuse this parameterized test for my turning left test cases. But I think that will get confusing. We'd be overloading this test. Remember from a previous video when we talked about TDD habits, the best tests only have one reason to fail. So if your test is about 2 things, it's about turning right and about turning left, we're overloading that test. We're making our test code more complex and harder to understand. So this is an example where we would actually leave some duplication in. I'm going to create another test for turning left. So I'm repeating stuff that's included in this first test, turns left, and we're back where we started, north to west. We're kind of back where we started. We're repeating the process. It's the same test, but with different data. So there's our rover. Oops. And have it facing north to begin with. And let's make it go left. There we go. Okay, let's rerun all our tests. So this should be a failing test because it doesn't know what left means. It doesn't know what right means at the moment either. It just does what it's told to. So it's currently actually turning clockwise. And then we would go into Rover and say, okay, well, if it's R, do this. Otherwise, do this. So we're kind of beginning again. This is how I started triangulating the behavior for turning right. Okay, and we would carry on in that vein, and we would end up with a bunch of tests, 4 tests for turning left, which I would have parameterized probably again at the 3rd test for turning left. So I'm going to pause the video slightly, and I'm going to fast forward a little bit, and you can see how this emerges. So we fast forwarded to, we've done all 4 tests now for turning left, and I've parameterized it, and I'm just about to rename this test so that it's more descriptive of all these cases. Turns left anti-clockwise. So we read those 2 test names, turns right clockwise, turns left anti-clockwise. Our test fixture is now beginning to read more like a specification of the rules of our Mars rover. So that's a very useful thing. And we have got some duplication set up in the test here, but it's only 2 examples, and at the moment I'm just not that worried about it. So I'm going to leave that. I'm going to leave some duplication in the test there because it makes the test hopefully easier to understand. Now, if we take a look inside our rover, I haven't refactored this yet. So what we're going to finish off in this video is just doing a little bit more refactoring inside our go method. So these blocks of code look very, very similar. In fact, the only thing that's different is which direction the compass goes in. Is it clockwise or anti-clockwise? The rest is the same. So what I'm going to do is I'm going to extract a helper method here for turning the rover in any particular direction. Let's call that turn. And which direction it turns in depends on the orientation of the compass. So let's do that. It's going to do it for both. Clever tool. There we go. And one final bit of business here is I'm just going to inline our compass. And I'll just do this one as well. Inline our compass so that it reads much more tidily there. Now remember what I said about duplication and the risk there that we end up making our code harder to understand, our test code for example, and the same is true here. We're turning in one direction or the other. The question is, which way are we turning? Are we turning right or are we turning left? So I could document that with a comment, turn right, but I tend to find that comments are a bit of an admission, that your code is difficult to understand. So instead of using a comment, let's document this by extracting into a method and use the name of the method to describe what it's doing. So right. Okay. I'm not quite sure what's happening here. I'm just going to cancel that. Why are you doing that? I have no idea. Okay, and again here, keeping an eye on that, turn left. Okay. No. Bit of weirdness going on there. We run our tests and it's still working all nice and good. So now we have a right method and a left method and a turn method. And we discovered those methods through the process of refactoring our code. We started by pulling on that string, pulling on that thread of duplication, and then other stuff revealed itself. I removed the duplication, and then to make this code easier to understand, I've extracted methods to document what's actually going on in those two particular statements. So the opposite of duplication is reuse, and when we refactor duplication out of our code, including our test code, we discover reusable abstractions. If we jump in too early and remove the duplication, there's a risk that we'll introduce the wrong abstraction. And if we jump in too late, there's a risk that we won't get around to doing it at all. So the rule of 3. On average, we wait to see 3 examples of duplication before we jump in and refactor. And there are times when we might choose not to remove the duplication because it makes our code, for example, our test code here, easier to read, easier to understand. So we leave some duplication in because code being easy to understand always wins over not repeating yourself. So there you go. That's video number 3. That's the relationship between duplication and design. In the 4th video, we'll be talking, in the 5th video, we'll be putting a lot of this stuff together and talking about 2 approaches to test-driven development: inside-out TDD and outside-in TDD.